pretty much for everything now. We're moving to it. We have some Django stuff that we're switching over to Go. My background, though, just so you know, is Ruby on Rails. I've been doing Go for about 4 months now. Things continue to work after we make changes. And then the last one would be that it influences our design. You all heard of TDD and how testing can set things up. Sort of the default design pattern is the ball of mud. You all familiar with the ball of mud pattern? Basically, I'm getting some looks. So basically, the idea is you start out and somebody asks you to build something. You're like, oh, that's easy. You build it. And then they say, oh, by the way, can you add this? And you go in, that's easy. You add that. And then they go and they, oh, can you add this? And you go in, you add the third thing, and that's fine. And you go to add the fourth thing that isn't any harder than the third thing, but because of things 1, 2, and 3, you really can't do 4 until you take the whole thing apart and start all over again. So a lot of times testing forces us to think about how people will use our programs and how we'll use our programs in the future, such that they have better design. We don't end up with elevator buttons that look like that. But more or less something, this is actually from a talk by Uncle Bob, where he talks about how to architect things so that they have boundaries that come together. And testing is a good way to make sure that we write our tests, write our applications so that they have good structure and good boundaries. So for this talk, we're going to go through a sample app, so we have sort of a little bit of a structure to talk about what we're testing and what we're putting together. The idea is it's going to be a simple app that sends appointment reminder text messages. So if you have an appointment with the dentist tomorrow, we want to send you a note saying, hey, you have an appointment tomorrow at 8 a.m. Let us know if you can't make it. And we're going to use Twilio as our text message sender, so we actually don't have to worry too much about that. We're going to start out with, so I'm going to talk first about tests that influence our design. And I see those as unit tests, really. And Go makes this super easy. So any file that ends in _test is going to be a test file. It exists in the same package as it's a package you're testing. We just include testing at the top, and then your function starts with text. So it's all pretty straightforward. We're going to look at a couple of these things. The first one, test helper, doesn't end in test. This is just a file that I put in my package that has a bunch of fixtures or methods that I'm using only to create a test environment. So they don't really carry out, they're not a part of the actual package. And then the Twilio test is what we're going to look at actually to sort of give an example of how to put this together. So first thing is that your testing files, part of the package that is testing, you're going to import testing. And then your function starts with test, and then you pass it this pointer to testing.t. Basically here it just is going to go through, and then if it fails, you just call t.error and tell it what you're missing, what you're expecting. So that's sort of the basic structure for how the unit testing goes. When you set it up, you just type go test, tells you if it passes and how long it took to run. You can see that that's really pretty quick, that we're 0.051 seconds from the test suite, which I think is one of the things that I love about Go. It gets you in a good rhythm, getting through, putting together your test, and then getting feedback quickly. So it gets you into the, like to call the TDZ zone, or the test-driven development zone, where you start out with passing tests, and you write a failing test, and you get a passing test, and you go back and refactor. You just go through that cycle. And I think for unit testing, this works really great. One of the things that Dave Cheney actually talked about too, that's sort of an expansion of this, is table-driven tests. The idea here is actually pretty straightforward. You just create a struct that has the expected value and then any parameters that you have to pass to your test to get those values back. And then you can create an array of these structs that has as many elements as you want. And then you just simply range through them and spit out your test. And that gives you an easy way to sort of structure a lot. If I want to run a lot of sample data through the same test environment, make sure that I get what I expected to get. This is from Dave Cheney's blog on table-driven tests. So there you can see we're just.
Is that an anonymous inline struct?
It's an anonymous inline struct, yeah.
I didn't know that was a thing. That's cool.
So yeah, it's just an easy way to set up something that's a quick data structure to sort through. So a lot of the things with writing tests, it helps us begin with the end in mind. And a good example of this is, you can see, again, the ball of mud. The first house on that hillside probably looked just fine, but by the time you get to this point, how do you get around in that city? It's hard to tell. And Salt Lake, as we all know, living here is a great example of a city that was well planned out for growth and has the infrastructure, the large roads and everything going forward. So unit testing helps us do this, even if just by accident, because we have to write our code in such a way that we can test it. It helps us get to this pattern. There's a couple of things that Carl Sagan gave some advice about how to write code that's easy to test and go. First thing he said was the difference between a method that's easy to test and is not as often matter whether you're passing interfaces, which are good, or concrete types, which are bad. We're going to get into some more stubbing or referencing. These don't make sense. We'll talk about these terms later, but mocking or stubbing and interfaces are a good way to sort of mock out a third-party dependency that you might have. So if you're passing an interface, you can create sort of like a fake interface that stubs out what you're wanting to do. So it gives you a lot of flexibility that way. And then also passing functions around. It's another way that you can write code that's easy to test and that decouples your implementations. So again, I'm going to go back to this. This is like a famous Ruby talk that Uncle Bob did. We talked about sort of going through and separating concerns. And he's also credited with this concept of SOLID, which is an object-oriented design pattern or philosophy. But I think it carries over well into Go. Basically, it's an acronym to help us to remember that our classes, in this case you don't have classes, but our functions should have a single responsibility. It should only do one thing. They should be open closed, which means you should be able to add new functionality without changing any of the existing code. The Liskov substitution means that doesn't really apply directly. It's sort of like you can take any subclass and put it in place of a superclass, but here we use interfaces. So anything that shares the same interface should be able to be substituted using that same interface. We should keep our interfaces narrow. And then dependency inversion. So we don't depend on things that we don't need to depend on. It makes it easy to have decoupled code. So that's just an easy way to sort of remember these things and go through it. So, and have a little bit of fun. The second reason why we test, right, is to make sure stuff works. And I have a couple of slides I thought were just kind of fun. I just wanted to go through and look at it. So we're gonna do some Pinterest fails. If you haven't seen these, they're a lot of fun. You should go look them up afterwards. But here, someone saw this on Pinterest. That's what they got, right? They had a couple turkey cookies. This was a bunch of pancakes put together to make a regular cake. I think that one was pretty awesome. Melted crayons. This is what my projects look like. And this was my actual favorite. That looks delicious, right? I just want to try that cake. That was pretty awesome. I don't know how you get to that for that. But anyway, so sometimes our tests, they want to prevent us from creating this kind of mess. It's totally different, for me, a different approach than unit testing or the TDD. We just want to make sure our stuff works, that it works together. Sort of a famous example of this is the Mars probe. I don't know if y'all see some people sort of smiling, but basically it was a collaboration between NASA and England. I don't know what their version of NASA is, but they co-developed this probe to go to Mars, and they tested everything and they sent it out, and it hit Mars pretty hard. And when they went back and they looked at it and they thought about it, it was because we use miles and they use kilometers. And for some reason, those measurements just didn't add up. So they needed to have something more than unit testing. We had to have something that tested those two systems together and made sure that they collaborated. And here's just another image I saw, the keyboard failure, press F1 to continue. I don't know how you're going to do that. But anyway, so some of the tools that Go gives us to test our systems together are in that HTTP test package. There's a response recorder and a server in here. And I'm going to give some examples. They're not actually, I went with a different route in our test, in our sample application that I was talking about. So Just pulled these straight off of their site. But basically the idea here is obviously you import the package, and then you create a func that just writes whatever you want to stub out in response. And then when you run, when you go through and you actually call the test new recorder and you pass it in to your handler, you get back the response they created. So that way, if you needed to talk to a third-party website, it would be easy to just stub out a sample server that gave you the response you were expecting from it. And on the back end, they do the same thing for creating a new server. Again, same idea. So those go back and forth. So we talked a little bit about. I brought this topic up. I didn't know that we came to a great answer last time we were talking about interfaces, about when to use interfaces, when to use structs. You know, Dave Cheney, or no, it was Carl Sagan that gave the advice that we should use structs as opposed to, or do it backwards. Interfaces make things easier to test as opposed to structs. But structs are kind of nice because you can reference raw data types. You don't have to have a getter or a setter to reference the information inside. And looking at the Go library, they do both. So it's not like I have a clear win, you know, based on the standard Go packages, what should be what. So obviously we talked about solid, and the D there is the dependency inversion. You don't want to solder a light bulb into the wiring, right? It's a lot of overhead. But then on the other end, or the flip side of that, is every time I use a lamp, I don't want to have to pick which cord I have to use with it. A lot of times it's nice just to have the package, figure that out and run it on its own. But when you're doing your tests, you don't actually want to plug it into the wall. You want to plug it into something else. And so you've got to sort of take that balance about how to attach your functions, your methods to things they depend on. One way of that is by mocking or using test doubles. This is the red-green again, going back to the red-green thing. Sometimes you can take an idea too far. Here they build a boat out of duct tape. Duct tape is great, but this might be a fun adventure, but not really the way you want to go if you're doing something. So there's a library that's with mock. The hardest part about it is actually getting it installed. It uses Lazar. Everything else I've downloaded is either Git or Mercurial. But this works. I had to install a couple of other things to get it set up. And then once you get everything installed, you just run with mock go test. And it'll run your tests and create your mocks for you. A shortcut for that is just mock test. So those bottom two lines are essentially the same thing. And how that sets up is you import the package into your test. And then on the item you want to mock, you're just going to put the comment with the word mock after it. You can go through and figure out what it's going to do with that. Here, DM is a data mapper. It's basically just an abstraction for our database. So it gives us basically, instead of having to write raw SQL, you can give it information that will generate the SQL on the back end. So if we're not wanting to actually interact with our database, it's a really nice place to just stub this out and say, if I give you these responses, this is the data set I expect to get back, and go through it. I have two tests that sort of depend on this. One, I'm going to pass it a message where I don't get any data back and I expect to have an empty set. The other one, I'm going to pass it some fake data and I actually want to get a patient with their number back and just verify that I got what I wanted to get through this thing. So one of the things that I don't really love about this mock is it takes a little bit of setup. You have to create a new controller. You have to make sure that you finish it when you're done, so you do the for finish line. You have to do this your package.mock set controller and then pass it that controller to it. But once that's set up, and that's pretty much the same every time you use it, it's pretty easy to then just use it like a mock in a lot of other scripting languages or anything like that. Basically, you just say that when I call, I'm going to, on my data mapper package, I'm going to call new. So expect me to call new. I'm going to pass it these parameters. And when I do, don't actually do anything that you normally do. Just return this item, which is this empty data manager mapper. It's just a struct. And so then you go through, you can set other expectations like that actual individual item that it's going to return. It's going to expect me to call with on it, order again, and then fetch. And when I call fetch, I actually want you to return another data structure that I'm giving you. So just give me this thing when you're done with all of that. And then I can test everything around it using that known data and get what we want, and then I'm just going to return that message. The other thing that these expects do is actually if you put in an expect and your method doesn't call that method, even though you're just saying that, sort of ignore this order thing, if you don't get that expect, it'll fail. So if you tell it that you should call something on it and it doesn't get called, then it's going to let you know and it's going to fail. So then the actual method just looks like we call that. Here's where I'm actually calling those things, and I just took a little sample from that other thing saying that. So all these places where I'm actually telling it what to call with, I'm giving it that sample data. That comes back. The other thing about that, it takes about 5 seconds when you start your tests for the mocks to get created, and then it runs pretty quickly after that. I don't notice any difference between how many mocks or how many tests that I do. That sort of takes that initial, when it compiles your program to run, to set up those mocks for you. So it's a little bit of an overhead, but it's not too bad. So that's one way around, stubbing out your dependencies. So obviously for what I did, I went with mocks, and I think a lot of that was because I came from a Ruby background where that's sort of how you test. Going back and doing more research and looking at how they have the HTTP server and the recorders, I probably would go back and redo it that way. It seems to be pretty straightforward and an easy way to give you a good, it's really easy for Go to set up a server that can give you sample data. And you just tell it what to give you, and you can run as many of those on your system as you want. It's not a problem. So that's something that I learned putting this talk together, and I'll definitely take that a different approach. So another thing that's always awesome to test is time. It's always a good time, right? In our application, when we're sending out these text messages, we don't actually want to send any out in the middle of the night because that would suck, right? So we want to write a control method that basically says if it's after 9 p.m. or before 8 a.m., don't send this out. But then how do you actually stub time, or mock time, so that when you run your test, you can pretend it's 10 a.m., 10 p.m., 6 a.m., these different times of the day, and then make sure that your application behaves appropriately. So on Stack Overflow, this was asked, is there an easy way to do this? And there was like basically a 3-step process for dealing with this in there. After I went through that for a while, though, actually on this question, they gave a pretty good solution, which was to create a wrapper around a time structure. So I'm just going to create a sample struct that all it has in it is one element that's current time. And then if that's nil, if you call current time on that thing, if that's 0 is the nil for a time object, then just give me the current time. If it's not, then that's the time that I want to pretend it is. And this would be kind of annoying if you had to put it everywhere that you use time.now, but really there's not too many times where you write code that has to behave differently different times of the day. And so in those few options where you do need to test that behavior and have that behavior that's dependent on what time it is now, it's not too bad to create something like this and then just inject it into your function. So that's really the worst of it, is when you call your verify hours, you have to pass it this time controller struct. Just here I'm just creating an old one because I want it to be time.now when I'm actually in production. And then when it gets called, it's going to that time controller.now is what I'm actually going to pull the time from when I calculate whether or not I can send this text message out. And then the tests are pretty straightforward. At the top, a little bit before the arrow, we're going to create something that's too late, something that's too early, and something that's okay. And then we write our test. The first 2 we expect to give them invalid time. The third one, we're going to get a valid time. Yeah.
Off topic, but from your screenshot, it looks like you're using Sublime Text.
Yes. So that's another carryover from the Rails world, although the Go format, the Go package in Sublime is pretty good. The format does really good. some of this stuff, I think there might be a package that I'm not using. The Vim guys like that it automatically turn on and off packages, standard packages that they're not using, that they're using. So this one, the Sublime Text, it doesn't do that for you, but everything else is pretty straightforward. It does the type ahead and all that kind of stuff. Yeah, and interrupt me because this is going to be a short talk if you don't. So that was just, I thought that was a good way to sort of go around and fake out time. I was just using something called time cop in Ruby, which was really nice for just sort of pretending you set a timer. It would actually stub out your Ruby. You can modify your running code at any time. Basically say when you call the Ruby record method to give you back a fake time. One of the other things that was really, I was blown away by how awesome this was actually the test coverage package that comes with Go. So at 1.2, they changed how they did testing, the test coverage part of Go. Basically, before you create your app, there's like a pre-compile state. And I'm going to be using all sorts of wrong terminology here, so I apologize. But basically, it goes through your code ahead of time, and it inserts statements. Basically, just an array where it tracks whether or not that code gets hit and how often it gets hit. And then it can create a stats file of that data. So that first line, that go test cover profile equals coverage.out, is basically telling you to go through and create that data about how often each line of code gets called when you run your test suite. And then the second one actually opens up a web browser that then points to that data and gives you some pretty good detail. I was going to take a minute and actually go and show what that looks like. Because again, I was really surprised by how great this was and how helpful it was. So right at the top, you can see you get a pull-down menu basically that tells you every file that's in this package and what percentage of code or what percentage of the code in that file is covered by tests. And then if you want to actually get more detail about it, you can click on, so you can see the highest one is my test helper package, which is no surprise. Because I basically wrote this only for the purpose of, putting fixtures and stuff into our tests. So it'd be pretty sad if that one wasn't tested. There's some other ones, you can see like I have a daemons one that just runs in the background. I don't have a great way to test that, so not really high test. This one though, I wanted to show. We're going to actually go through one of the files, and so each one you go through, you can see the stuff that's grayed out. It's just stuff that it doesn't bother to get tested. You're not going to test your import statements. You're not going to test your structs. Then everything that's green is something that has test coverage. So you can scroll through and you can see that I'm covering half of this test, but there's one case that I'm missing. So it's really easy to see that I don't have good test data to go through and give me that I need something where I don't have a preferred name set. This is just me anticipating a change in the future, so it doesn't really, probably should still test it, but it's not something that we're actually doing today. One of the things that did jump out at me, I was trying to come in here and they're saying your appointment's on the 22nd. You want to get the verbiage right. We have an ND or TH or an RD if it's the 3rd or the 1st. And I just missed the 2nd and the 22nd, so the test data probably should have some appointments that are on those days, so just make sure that those are coming out to everyone. But that's really not, I just thought it was really awesome that it was so easy to go through and see exactly the weaknesses in your tests. So you go through and put something together that was a little more robust. It's really quiet. I don't know if that's a good sign or a bad sign. But so then another thing that tests can do is there's another part of the test suite of benchmarks. So benchmarks are a lot like tests. They're part of the testing package, but they're designed to tell you how long it takes to run certain parts of code. And they're set up pretty much the same way, but instead of starting with tests, they start with benchmark. Instead of passing testing.t, you pass testing.b. One of the things that's sort of a little confusing for a lot of people. This is again from Dave Cheney's blog post, so not just me. It confused me at first. You're going to have a number called b.n, and a lot of times it might be tempting to use that number in your test, but basically that's calculated by the compiler, and it uses that to determine how many times I have to run this test to have it run for at least a second, so it can get a reasonable sampling of how long it takes to do the code that's in there. And then the other thing is you have to pass, if you pass the dash bench option with your test, you have to give it a regular expression for the test to match. With just test, you can just go test and we run all the tests. But with bench, you have to give it this dot that represents everything. It's a little weird.
So are these benchmark functions, do they have to be in _test.go files too, or can they be in other files?
They do.
They do have to be in, okay. I never tried it in a not _test, but.
I think that's incorrect. I believe it actually calls this function multiple times. So the first time it calls it, b.n is 1, and it uses that to gauge how many more times to call the function. It actually dynamically does it at runtime.
Yeah, so it calculates what n needs to be so that it runs long enough. Is that, or are you saying
that's a
something
runtime step, not a compile time step. That's
Oh, runtime step. Okay, I apologize.
No, it's
But the same idea. It's not something that you as a developer manage. It's something that Go takes
right.
care of.
We're
for
realizing
you.
that don't put setup in front of the loop there generally, or it will screw. Never mind. I had a situation where I was putting heavy setup there, assuming that it would run exactly once.
Okay.
It actually calls your function multiple times for the test run, and so use init functions to do that kind of setup stuff rather than
Then
a
inside
little
the
tip.
loop.
Yeah.
No, that's a good point. One of the other things so I didn't have that in the gotcha. Dave Cheney gave us a couple of gotchas, the traps, right? Basically, they said a couple of things that people that are new to benchmarking do is they'll try to do like this fib n in here. And so when it's running, it's trying to come to a stable time that it takes to run this, and if that n is always changing, then it's going to take longer to run that function every time it runs it. So it never comes to something that it thinks is a steady value that it can return. Same idea down at the one below it, where it's just passing in that value that it generates. And it seems like it can make a lot of sense to do that it's generating this number for you. You should do something with it. Basically, it's doing that to determine how many times to run this code to make it a reliable benchmark. And then this last one I actually demonstrated above, it's not here. I'm going to go back. Due to compiler optimizations, so above here I declared a variable called result. That's a package level variable. And then at the end, when I'm done, I'm going to pass error, which is calculated inside that loop, into that result. Because Go is smart. It might realize that you never do anything inside this loop. You're ignoring the data that you return, so I'm just not going to do anything with that loop and just skip it altogether. So this is sort of a way to tell Go, don't ignore this. You have to, I need you to do this step. So some other things that are sort of good to go look at, go help test flag, and then go test run equals, and you can give it a regular expression. That way you just run specific tests if you don't want to do your whole test suite. Although, again, I haven't been doing Go for too long. The stuff I'm working on is really small, but I haven't had anything that takes even a second to run the test. So it's not really a penalty to run a lot of tests if you're not interested in. They just seem to go super fast. So the next thing that I really wanted to talk about is profiling in Go programs. I don't know if you know Isabella, but she's always asking, what you doing? What you doing? And that's sort of how profilers work. It says 100 times a second, it just asks what you're doing. And so this is sort of like the complement to benchmarks. Benchmarks tell you exactly how long a certain process takes to run. Profiling tells you what percentage of the time your program is spending in given functions. So if something takes a long time, it's more likely that it's going to hit it every time it profiles. It's going to say, oh, I'm doing this thing, I'm doing this thing. And you can see which things it's spending a lot of time in. And TestLib provides some great flags that help with this profile. And then The sad part is it doesn't work in OS X. And I spent a good couple of hours trying to get this to work before I found this bug, basically reporting, I guess, that basically what it comes down to is that multi-threaded CPU profiles do not work in OS X. And the worst part is they don't tell you that they're not working. You just sort of get a file that looks sort of silly, and you go to look at it, sort of get like an empty set, is what it looks like. Or it says you're spending 100% of your time doing something. So unfortunately, this talk's going to be a little shorter because that's about all I could get, all the progress I could make on doing the profiling. They have some really great tools. Sort of works like the test profiling where it'll save stats into a file, and then you can open that up, and they have some graphing tools. You can look at that, and it'll sort of does like, things where you spend more time will get bigger, so it's really easy to graph and see where you're spending your time and go through and look through it. I just didn't have a way to run the profile to sort of show you how to do it, and didn't want to talk too much about something that I didn't get working.
Have you tried it in a Vagrant or Docker or something like that?
That is a good idea.
Yeah, I've done it that way. Fire up the Vagrant box in Linux and it works great.
All right. So does it work pretty much the same? Like, the way I understood it, I never got it to work. Basically, you can pass these flags, the CPU profile and the mem profile.
Yeah.
On your test
It ends
suite.
up telling you what functions are it's putting the time into and all that. So yeah.
So that way you can sort of track down and see which items you want to work on refactoring and make you run faster. Another great tool is the race detector. You can just put -race on the end of your command, either if you're in development you can do it, or on your test you can run it. One of the things I didn't put the code in here, but Dave Cheney talked a little bit too about if you're doing race tests, you should put your code under load test. So you do like the Apache benchmark or something to sort of hit it, because some race conditions aren't apparent until your code is under load or heavy load. But basically what it does is just sets up something and sees the two things try to access the same piece of memory at the same time. If it does, and it lets you know about it, gives you a warning. And unfortunately, or fortunately, that is all I got. So those are the references to it. But like I said, I'm new to Go. I have a lot of opinions and ideas about how to test things, and felt like I got a lot of benefit out of testing in other languages that I came from, trying to explore different ideas. So I'd love to talk about anything. If you guys have questions or ideas or things that have worked for you.
I'd be curious to know what other testing libraries other people are using. We're using something different than with Mock, but we actually use one called Go Convey, which has a nice GUI interface as well. But I'd be interested in knowing what other people are using and why they like it for testing.
We have a strict rule against using any test library, period.
Just the standard Go stuff.
Yeah, because when you introduce a testing library, now you've introduced another sub-language, and it's better if your tests just look like the language that you're working in. I could argue against that, but coming from C++ and like things like Google Mock, but you need some, like maybe once Go generate is there, something like that'll happen, and that might be nice. But yeah, but on the flip side of that, for mocking, we're very disciplined, and if you create some library or something that interacts with the real world, which is most of them, you have to write a mock, like for the rest of the company, so that people can test your code. And usually it goes in like a sub package called test or something test.
Does that mock live alongside normal code in the same package?
Yeah, there's a sub package like test or something, like
Okay.
whatever test.
Like an IOUtil kind of idea.
Right. So yeah, exactly. That way you don't have it included in all your code.
Right.
Yeah.
One thing that I would comment on your test helper, your big useful fixtures, is that since it doesn't end in an _ test, it would actually be compiled into your binary. where you wouldn't necessarily want the test fixtures in there. So if you just leave it as underscore test, still using your fixtures, you can use it the same way.
Okay, that's a good idea. I didn't know, I knew that Go was smart about what it didn't compile. I didn't know, like if it wasn't referenced anywhere else, it would.
I guess if
skip
it's
and
not referenced, it may not be used, actually.
Optimized down.
Yeah, but if you did something like on an init function where you echoed something out, it would be printing out, but obviously, if it doesn't do anything like that, and you're not using one of the functions, then it may not be.
Yeah, and the reason why I did it, and it probably I could have been doing something inside of it I shouldn't have been doing, was it like complain that I didn't have any test functions inside of it at one point or something like that. Like a test file didn't. So I didn't do exhaustive why I got that error message though, so it probably was doing something else wrong to get that. So I just changed it around and went with it that way.
I would say we're on the same boat of not really using any of the other testing libraries. Some of it comes from, like GopherCon, there's a really good talk that's on YouTube from, I think it was SoundCloud. And they said that they've tried out a bunch of just different testing libraries, and for them, they kept coming back to the built-in Go stuff. And for us, we built our own little kind of tester package where we some standard mocks or kind of environment variables, that kind of thing, that we include in our own stuff, but it's pretty minimal. So yeah, we've tried a couple of those different testing frameworks, and same thing. Instead of writing Go code, you're writing framework code that may or may not be useful down the road.
Another thing along with that I feel like has helped us a lot in our testing is with doing your own, just you can do a small package that kind of prints stuff out in a pretty way when a test fails. And because that was one of the biggest things one of the biggest hurdles was when a test fails, you want to see why it failed and what changed. Why did this test pass before and now it's not passing? And you can do that just by creating a small package that will print it out in a nice way for you. So.
That's a good idea. I don't know if there are any. I don't know if you. It sounds like you wrote your own, but I don't know if there's any that you know about that are out there that sort of have favor for doing that kind of thing.
Yeah, I don't know. We just did our own.
One that kind of does it a little bit. It's by Stretcher, I think, if not without an E. Testify. It's Testify, and they have a suite and other stuff included with it. They do some 3D printing, but we ended up doing our own with just the standard func printf package. You can set it's got it built in where you can kind of set some padding and for specific column widths, and you can just print it out like that, and it's pretty easy to get stuff lined up.
Does it take like the regular escape character? The regular escape characters for colors and stuff like that? Does it have, or do you know, or I don't know if you've messed with that?
We haven't done any color output.
Okay. You can at least get it formatted and aligned in a way that makes it easy to read.
So for us, like when we run our tests, it kind of looks like Linux boot up, where it outputs a line for every test that's running, and then it does kind of a pretty print box on a test failure.
Awesome. So one of the things I really liked the thing that I did where I stubbed the time. I thought that it wasn't Go, or it was Go, it wasn't an extra package. One of the things I didn't like about it is I didn't like that I had to inject it into the method, and if it was something that I used a lot, it's kind of nice if you can just have a package and you can reference that package and pull something in. I didn't know if y'all, is there another way to do that that's better? Yeah.
I've made like a package variable that's a func, and it'll just initialize it to time.now. But if my test wants to replace that variable with a constant thing, it will just replace that variable with a func, and it's a little lighter, but essentially the same thing.
That's a strategy we use a lot, is making the package
And it doesn't have to be exported because the test shares that same package.
Right.
And then you can just the test can just overwrite that package variable with whatever func you want. And then in your test, you just set the package function to instead of time.now, time.mock, time whatever.
Right.
And then the rest of your test will use that. You do that correctly.
Yeah, no, it's a great idea.
One thing we do is typically, for some of our stuff that's doing time.now, a lot of times we can check and say, okay, let's make sure it's not a nil time, and then when we're doing like a comparison for test passing or not, we'll just eliminate the time function or part of it, and then do a reflect.beep equal or something to make sure our struct matches. So we can say, okay, is it not nil, and if so, it was set. And most of our code doesn't that's not a point of failure.
Okay, yeah, that's good. I don't know if anybody else, I don't know that I'm answering the questions, but I think it's good questions, good discussions. I don't know if anybody else has any other things they want to bring up or talk about.
So I just ran into B false and B falsy with RSpec about a week ago. You know about that?
No? A falsy? Is that a
B false versus B falsy?
falsy?
Okay,
Okay, so
expect to be falsy will be false.
Oh,
And
I see.
I'm really glad with Go. I'll probably never run into that ever.
So he's referencing a Ruby issue where if something is falsy, it's not necessarily false.
Yeah.
So,
I lost a day on that.
yeah. So there are two different things. I've been away from it long enough now. I can't think of a great. Do you have a good example of something that's?
You know
That's
what? I had
falsy?
B false, and the value was actually false. So I don't know why that wasn't working.
That wasn't working.
But you know, you can just do B false. But the night though, so like to beat a dead horse here, not having testing frameworks, you avoid that whole sinkhole.
Whole issue. So, yeah, it's kind of nice not having a testing framework, but I also sort of
You feel like you type a lot.
feel like I type a lot. I also feel like testing frameworks gave me an indication of. They answered a lot of questions that maybe if you're new to a language, it's sort of this is a way to set it up, and if you're fighting it too hard, you're probably doing it wrong, something like that. And I get a little bit of that in Go, but I miss that. But I agree with you. I don't miss. What does falsy mean to the person who wrote this library as opposed to something else?
Interesting. You mentioned the Suite library. Do you guys actually use that?
We tried it and then went away from it. It was just a lot of overhead and
Right.
really locking it into the thing. So we actually built my tests, used it, and then kind of said, this is done.
Right. To say Go 1.4 is actually adding a real way to do that with the test main function. So you can do like setup stuff and then say run my test and then do more teardown stuff. So I think it's interesting to see them actually trying to help people that need to use libraries for some of that stuff, not need libraries for that kind of stuff. It's kind of fun.
What we did when we wanted to manage it like that was, because it only runs things that start with like a capital test.
Right.
And so we would just have one function that was test main, and everything else would be like lowercase test something,
Right.
and run it from that main function.
All right.
The only thing that kills is you then can't run tests one at a time. You have to run the whole
Right.
package test.
Is there anything else anybody wants to?
No, I just parked it.
Just if you're testing against SQL, there's a really cool thing called SQL mock, and it's a SQL driver, and it's been a lifesaver. It's kind of, it kind of stinks to use, but it's something.
It's something that's there.
Yeah. So it's useful.
Interesting.
That'd be good. We actually have like an abstraction of our, so not like writing JavaScript queries as JSON queries and passing to an HTTP thing. So I wasn't like my data mapper isn't really writing SQL. But that's good to know.
For us, what we end up doing for all of our data packages, we kind of have our little wrappers, and they're like, data stored output or whatever we write. And then we use, like Brian was saying, where you set those as a variable. And because we're doing it across packages, we have it as an exported variable, like, right, if capital put is just a variable, and then the function internally is a lowercase put. But then in the test, we can just overwrite that variable with a function that, hard returns what your expected value is. So you don't have to set up any kind of mock. You just, in our table testing, we just have some anonymous functions that match the right signature and return it.
Do you find that that's like, have you also tried doing an interface that maybe has the same signatures, matching interface, but the underlying data structure gives you different values?
The problem we have with that is, we have data access all throughout our code, and we're typically not passing in, the function into the interface that's doing it. It's
grabbing its own thing.
Right, it's running and then just storing it out wherever it needs to. And so that way, we can kind of globally override it, and it makes testing a lot easier.
The only problem with that is when you have two of those functions in the function that you're testing, because you can only override it once in there. So if you need two different outcomes within the function you're testing, then that doesn't work as well.
But we found that typically, when that's the case, if we're doing multiple, SQL calls or whatever in one function, it means we can probably break it down into, a couple of separate ones.
So in an application that we're writing, we knew we were going to have some data access to some data store, but we wanted to abstract that away from the actual code that's grabbing that data. So we used an interface to say, okay, this is the data that we're going to need. This is how if you implement this interface, you know how to get the data I want. I don't care all of the application above that layer. It doesn't care where that data is coming from. We support a MySQL backend or a level DB backend, or even a JSON flat file backend. Or in the case of testing, we implemented a dummy backend, which implements that interface to get access to that data. And then it just hard codes the return values. So for testing, basically the top most of our code